refers to the release of pollutants into the air that are detrimental to human health and the planet as a whole. It is also a mixture of natural and man-made substances in the air we breathe. So there are two categories of air pollution. The first one is outdoor air pollution, which involves exposures that take place outside of the built environment. Second is indoor air pollution, which involves exposures to particulates, carbon oxides, and other pollutants carried by indoor air or dust. So examples under outdoor air pollution. First, fine particles produced by the burning of fossil fuels, the coal and petroleum used in energy production. Second is noxious gases, sulfur dioxide, nitrogen oxides, carbon monoxide, and chemical vapors. Next is ground level ozone, which is a reactive form of oxygen and a primary component of urban smog. And the last is tobacco smoke. Examples under indoor air pollution include gases, which are carbon monoxide, radon, etc., household products and chemicals, building materials such as asbestos, formaldehyde, lead, etc., indoor allergens, cockroach and mouse growing, etc., and tobacco smoke, and mold and pollen. So what causes air pollution? So pollution enters the Earth's atmosphere in many different ways. Most air pollution is created by people taking the form of emissions from factories, cars, planes, or aerosol cans. Secondhand cigarette smoke is also considered air pollution. These man-made sources of pollution are called anthropogenic sources. Some types of air pollution, such as smoke from wildfires or ash from volcanoes, occur naturally. These are called natural sources. So air pollution is most common in large cities where emissions from many different sources are concentrated. Sometimes mountains or tall buildings prevent air pollution from spreading out. This air pollution often appears as a cloud, making the air murky. It is called smog. The word smog comes from combining the words smoke and fog. So these are smog and fog. So what are the effects of air pollution on the environment? Like people, animals, and plants, entire ecosystems can suffer effects from air pollution. Haze, like smog, is a visible type of air pollution that obscures shapes and colors. Hazy air pollution can even muffle sounds. Air pollution particles eventually fall back to the earth. Air pollution can directly contaminate the surface of bodies of water and soil. This can kill crops or reduce their yield, and it can kill young trees and other plants. So, sulfur dioxide and nitrogen oxide particles in the air can create acid rain when they mix with water and oxygen in the atmosphere. These air pollutants come mostly from coal-fired power plants and motor vehicles. When acid rain falls to earth, it damages plants by changing soil composition, degrades water quality in rivers, lakes, and streams, damages crops, and can cause buildings and monuments to decay. Like humans, animals can suffer health effects from exposure to air pollution. Birth defects, diseases, and lower reproductive rates have all been attributed to air pollution.
Waste management. With the increasing urbanization, solid waste management is a major global issue that governments face daily. The overproduction of waste has been causing negative impacts on our environment. Waste reduction and valorization need to be taken to the next level. What are sustainable solutions for waste disposal and management? What is waste management? First of all, there are many types of waste. Municipal, household, commercial, and demolition waste. Hazardous, like industrial, biomedical, electronic, or e-waste, radioactive, etc. Waste management includes the collection, transport, valorization, and disposal of this waste. More broadly, it includes any activity involved in the organization of waste management from production to final treatment. The main principles of waste management are first, waste hierarchy, referring to the 3 R's rule: reduce, recycle, reuse, and recycle. Waste prevention and minimization being the most desirable goal. Second, extended producer responsibility, adding all the environmental costs to the market price of a product, including end-of-life disposal. The polluter pays principle, requiring that a waste generator pays for the appropriate disposal of the waste. Waste disposal method. Each type of waste corresponds to a management process. To properly manage waste, pre-sorting is necessary. This sorting allows the separation of recyclable from non-recyclable waste, and subsequently the energy recovery. Waste management benefits. Sustainable waste management is a key concept of the circular economy and offers many opportunities, like economic. Waste management involves collecting, sorting, treating, recycling, and when properly facilitated, providing a source of energy and resources. Therefore, it has a huge economic potential that needs to be leveraged by public and private entities. Social. Besides creating jobs, improved waste management leads to a better quality of life for local populations. By improving hygiene conditions and reducing health risks related to illegal dumping and inadequate garbage collection. Environmental. The main advantage of sustainable waste management is to lessen the impact on the environment by providing air and water quality and contributing to the reduction of greenhouse gas emissions. Besides, reducing food waste also helps reduce the heavy environmental cost of producing more. Challenges and disadvantages. Hazard. The first one, while promoting recycling, is to make sure both consumers and recyclers are protected from toxic and dangerous substances that can be found in waste. High cost. Moreover, this cannot be seen as a short-term lucrative investment, as it obviously requires a lot of money to implement sustainable waste management strategies. Quality and recycled products. Downcycling, the recycling process that turns waste into products of inferior quality, can cause a problem regarding the quality of secondary products.
Toxic and hazardous waste management. Difference between toxic and hazardous. Toxic is generally used as an adjective to show that something contains or is a harmful or poisonous substance. Something toxic can cause serious illness, debilitation, or even death. Toxic is a specific property relating to a substance that makes it poisonous, while hazardous is the adjective form of hazard. Since hazard means a source of danger, hazardous means involving risk or danger. It can mean dangerous in the sense of being toxic. A hazardous substance contains some properties such as being toxic, flammable, reactive, or otherwise dangerous and risky to use in some way. A toxic substance is always hazardous, but a hazardous substance may not be toxic. Toxic waste. Toxic waste can harm people, animals, and plants. Whether it ends up in the ground, in streams, or even in the air, some toxins such as mercury and lead persist in the environment for many years and accumulate over time. Humans or wildfire often absorb these toxic substances when they eat fish or other prey. In the US, toxic waste has been overseen by the Federal Environmental Protection Agency or EPA since 1976, as well as state departments of environmental protection. Many toxic waste dumps that still pose a threat to communities are holdovers from the era prior to 1976. Other waste sites are the result of more recent illegal dumping. Types of toxic waste. So, toxic waste products are divided into three general categories: the chemical waste, radioactive waste, and medical waste. So, chemical waste, such as those that are considered corrosive, flammable, poisonous, reactive chemicals in the products. They are mostly found in products that you buy from the store, such as cleaning products, rat poison, and pesticides. So radioactive waste is waste that has been affected by radiation or emits radiation. Radioactive waste usually comes from the nuclear power plants. They may have been the old fuel rods that were replaced recently. Radioactive waste is usually stored deep underground, covered in concrete, since they emit a lot of radiation that harms people. Radioactive waste can be anything, even soil that has been affected by radiation. Medical waste is any kind of waste that has been infected by viruses, diseases, blood, human fluids, etc. They include used needles, band-aids, catheters that are designed for one use or cannot be sterilized after being used in an operation. It is very dangerous since people can be exposed to severe diseases that are on the waste. Medical waste usually comes from hospitals, healthcare facilities, and research labs. Hazardous waste management. Hazardous waste characteristics. Hazardous waste are classified on the basis of their biological, chemical, and physical properties. These properties generate materials that are either toxic, reactive, ignitable, corrosive, infectious, and or radioactive. Toxic waste are poisonous, even in very small or trace amounts. These are the acute effects of toxic waste. It causes death or violent illness. The chronic effects that can slowly cause irreparable harm. Some are carcinogenic, causing cancer after many years of exposure. Others are mutagenic, causing major biological changes in the offspring of exposed humans and wildlife. Reactive waste are chemically unstable and react violently with an air or water. They cause explosions or form toxic vapors. Ignitable waste burn at relatively low temperatures and may cause an immediate fire hazard. Corrosive waste includes strong acidic or alkaline substances. They destroy solid material and living tissue upon contact by chemical reaction. Infectious waste include used bandages, hypodermic needles, and other materials from hospitals or biological research facilities. Radioactive waste emit ionizing energy that can harm living organisms. Because some radioactive materials can persist in the environment for many thousands of years before fully decaying, there is much concern over the control of these wastes. Remedial action for hazardous waste. One option, going back to treatment, hazardous waste can be treated by chemical, thermal, biological, and physical methods. So chemical methods include ion exchange, precipitation, oxidation, and reduction and neutralization. For thermal methods is high temperature incineration, which not only can detoxify certain organic waste, but also can destroy them. One problem posed by hazardous waste incineration is the potential for air pollution. So biological treatment of certain organic waste, such as those from the petroleum industry, is also one option. One method used to treat hazardous waste biologically is called land farming. In this technique, the waste is carefully mixed with surface soil on a suitable tract of land. Microbes that can metabolize the waste may be added along with nutrients. In some cases, a genetically engineered species of bacteria is used. Food or forage crops are not grown on the same site. Microbes can also be used for stabilizing hazardous waste on previously contaminated sites. In that process is called bioremediation. Physical treatment concentrates, solidifies, or reduces the volume of the waste. Physical processes include evaporation, sedimentation, flotation, and filtration. Another process is solidification, which is achieved by encapsulating the waste in concrete, asphalt, or plastic. Encapsulation produces a solid mass of material that is resistant to leaching. Waste can also be mixed with lime, fly ash, and water to form a solid cement lime product. Surface storage and land disposal. For such waste, land disposal is the ultimate destination although it is not an attractive practice because of the inherent environmental risk involved. Two basic methods of land disposal include landfilling and underground injection. Prior to land disposal, surface storage or containment systems are often employed as a temporary method. Temporary on-site waste storage facilities include open waste piles and ponds or lagoons. New waste piles must be carefully constructed over any previous waste and must comply with regulatory requirements similar to those for landfills. A common type of temporary storage impoundment for hazardous liquid waste is an open pit or holding pond called a lagoon. Landfilling of hazardous solid or containerized waste is regulated more strictly than landfilling of municipal solid waste. Hazardous waste must be deposited in some so-called secure landfills, which provide at least 3 meters of separation between the bottom of the landfill and the underlying bedrock of groundwater table. A secure hazardous waste landfill must have 2 impermeable liners and leachate collection systems. A groundwater monitoring system that includes a series of deep wells drilled in and around the site is also required. Another option for the disposal of liquid hazardous waste is deep well injection. It is a procedure that involves pumping liquid waste through a steel casing into a porous layer of limestone or sandstone. High pressures are applied to force the liquid into the pores and fissures of the rock where it is to be permanently stored. The injection zone must lie below a layer of impervious rock or clay and may extend more than 0.8 kilometers below the surface. Deep well injection is relatively inexpensive and requires little or no pre-treatment of the waste, but it poses a danger of leaking hazardous waste and eventually polluting subsurface water supply. Remedial action. So one option for remediation is to completely remove all the waste material from the site and transport it to another location for treatment and proper disposal. This is so-called off-site solution. It is usually the most expensive option. On-site remediation, it reduces the production of leachate and lessens the chance of groundwater contamination. On-site remediation may include temporary removal of the hazardous waste, construction of a secure landfill on the same site, proper replacement of the waste, treatment of any contaminated soil or groundwater. Treated soil may be replaced on-site and treated groundwater returned to the aquifer by deep well injection.
So moving on to water environment and air pollution. So this covers the conditions of air, water, solid environment, and air pollution from engineering projects and other sources. So the water environment, ensuring a sustainable water environment for people and natural ecosystems requires the development of well-informed environmental policies and well-designed systems. So in order to achieve this goal, we must employ a holistic approach that draws on inputs from a wide variety of disciplines. So effective solutions and new approaches. So the water environment includes coastal zones, rivers, lakes, estuaries, groundwater, soil water, and even the atmosphere as part of the hydrologic cycle. It is now clear that the management of the water environment for sustainable human benefit requires the development of environmental policies promoting ecosystem health and human safety with accordant management and operation of facilities in ecosystems. So extending traditional boundaries. So traditionally, civil and environmental engineers have focused on studying parts of the systems or designing specific components of an engineered system, such as studying the dilation of effluent achieved through an ocean outfall in order to design an appropriate diffuser. So our attention now extends
the performance of individual components to the performance of whole systems, and the interaction of different systems with each other. For example, the influence of large water project operations on estuarine and coastal fisheries. Developing knowledge tools. So, given the complex problems facing the planet and the need for efficient and cost-effective strategies, we are focusing our efforts on the scientific, engineering, economic, social, and political aspects in an integrated and comprehensive way. So, we are leveraging our strengths in building multidisciplinary teams that may include, for example, experts in social sciences, biology, or other fisheries. So, within major research thrusts in areas such as water supply and treatment, coastal zone problems, and groundwater, we are emphasizing the development of comprehensive analytical, numerical, and observational tools that enable us to characterize the physical, chemical, and microbial environment, as well as to translate this knowledge into design principles and management policies. So, we are down to the question, what is water for the environment? So water that is allocated and managed specifically to improve the health of rivers, wetlands, and floodplains is known as water for the environment. Another question, why water for the environment is important? So healthy rivers and wetlands support native wildlife alongside a range of industries, including irrigation, dryland agriculture, fishing, tourism, timber production, and beekeeping. So rivers and wetlands also have great cultural and spiritual significance to Aboriginal people. These landscapes provide a link to traditional storytelling, beliefs, and practices. They are also a rich source of food, medicine, and materials for shelter, clothing, and tools as part of their living culture. What water for the environment does. So during dry times, water for the environment is used strategically to provide refuge sites for key plant and animal species, ensuring their survival in the longer term. Environmental flows help to recharge groundwater systems. Rivers and wetlands also cool the land around them. They help to slow fast-flowing flood waters and filter the water running through them. So flows spread out onto the floodplain, depositing sediments which in turn enrich the soil and increase productivity for agriculture. So water pollution, when we say water pollution, it is when waste, chemicals, or other particles cause a body of water such as rivers, oceans, lakes, to become harmful to the fish and animals that need the water to survive. Water pollution can disrupt and negatively impact nature's water cycle as well.
What are the main types of water pollution? When we think of Earth's water resources, we think of huge oceans, lakes, and rivers. Water resources like these are called surface waters. The most obvious type of water pollution affects surface waters. For example, a spill from an oil tanker creates an oil slick that can affect a vast area of the ocean. A great deal of water is held in underground rock structures known as aquifers, which we cannot see and seldom think about. Water stored underground in aquifers is known as groundwater. Aquifers feed our rivers and supply much of our drinking water. They too can become polluted. For example, when weed killers used in people's gardens drain into the ground. What are the effects of water pollution? Take oil spills, for example. They can happen if tankers are too poorly built to survive accidents at sea. But the economic benefit of compromising on tanker quality brings an economic cost when an oil spill occurs. The oil can wash up on nearby beaches, devastate the ecosystem, and severely affect tourism. The main problem is that the people who bear the cost of the spill, typically a small coastal community, are not the people who caused the problem in the first place. The people who operate the tanker. Yet, arguably, everyone who puts gasoline, petrol into their car or uses almost any kind of petroleum fluid transport contributes to the problem in some way. How can we stop water pollution? First, education. Making people aware of the problem is the first step to solving it. Second, laws. One of the biggest problems with water pollution is its transboundary nature. Many rivers cross countries. while seas span whole continents. Pollution discharged by factories in one country with poor environmental standards can cause problems in neighboring nations, even when they have tougher laws and higher standards. Third, economics. Most environmental experts agree that the best way to tackle pollution is through something called the polluter pays principle. This means that whoever causes pollution should have to pay to clean it up one way or another.